screen sharing. Let's see. Yes, it should be coding. Before I share my screen, let me quickly do this. Insert a page. Yes, insert a page there. Okay, then it's fine. I think I'm ready to share my screen. And let me do that. Okay, guys, just a quick check. Are we all okay there, honorable members? Can you see my screen? Can you clearly hear me when I speak?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Then it's fine. It's fine. It's fine. It's fine. And let me see. Okay. Then it's fine. So what we are going to be doing in today's lesson, it serves as a to some of you, but a continuation of what we have started to the other honorable members. If you guys remember, on our previous lesson, we discussed calculations related to the distance, the gradient, and the midpoint. And we also did an exercise where we had to calculate the distance, gradient, and the midpoint. In today's lesson, I want to continue from that lesson, but we're going to introduce some new things. Let me maybe take this opportunity to indicate that the topic that I'm talking about is analytical geometry. Okay, so maybe let me just have a list there and say distance. All of us, we should be able to calculate the distance. Number 2, the gradient. Number 3, the middle point, So that means all of us by now, we should be in a position to be able to calculate the distance, gradient, and the midpoint. So now, in addition to all that we've discussed, I would like for us to discuss something very much important. I'm curious to know as to which one to start with. Maybe let's start with what we call angle of inclination. Angle of inclination, which means whatever that we're going to be doing is degrees because it is an angle. Most importantly, let me actually explain it in this way to say, we will have a Cartesian plane. This is a Cartesian plane having the x-axis and the y-axis, obviously that being the origin. So you may be having a line, something of that nature. It could be a continuous line or whatever the case may be. Let's say maybe this is not even y, let me say function of f being f of x, or the graph of f being a straight line. When we talk about an angle of inclination, it is always an angle that starts from the x-axis going in that direction of anti-clockwise. This is the angle of inclination. Okay, what if we've got now a line which is like that? Remember, guys, a line that ends in the first quadrant and the third quadrant, it will always have a positive gradient. Just remember that when you have to calculate the gradient. One that ends in the second and fourth quadrant, it will always have a negative gradient. So that means the angle of inclination, honorable members, it is the one that starts from the x-axis until it hits the function. So that will therefore be our angle of inclination. So always when we calculate an angle of inclination, we must get a positive number. If we don't get a positive number when we calculate for the angle of inclination, then you must plus it by 180 degrees. I'm just trying to simplify it for now. So what is the formula to calculate angle of inclination? We have a formula which says tan of angle of inclination equals to the gradient. The gradient that you know how to calculate, it is there on that formula. So now, this is the situation. The moment we have a positive gradient, guys, I did notice that I'm disconnected. I will try to connect again. It looks like it's because maybe the battery was low on this device. I've now plugged it to the charger and I'm preparing to connect again. I'm now curious to know if that information is saved, and I don't think it's saved. I really do not think it is saved, but it's fine. Okay, I'm about to join again using that same device. I'll be leaving on this one just now. Let's see. Okay, sengibuyile manje. Let me quickly go back to where I was writing. No. That information has disappeared. But it's fine, even if it has disappeared. Luckily, it is on record. So I'm going to share my screen. Then from there, I will then continue. I think I still remember what I drew. Can someone just confirm for me if everything is okay now? Can you clearly hear me? Can you see on my screen?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
And it's fine. So very quickly, let me try to redraw that. I had X and Y, and I said this type of a line will always have a positive gradient. That is the line that ends in the first and third quadrant, and this one, it will always have a negative gradient. And what I was saying was the angle of inclination will always be that angle there, or it will be that angle there. Something that you should be aware of, which is what I've noticed, is that you will always get a negative angle when you calculate for angle of inclination when your gradient is negative, and you will have a positive angle when your gradient is positive. So this one that is negative angle, you will always plus it by 180 degrees. I'm going to explain to you shortly why you have to plus it by 180 degrees and why it gives you a negative angle. So before I disconnected, I was saying this is the formula to calculate angle of inclination. Is equals to the gradient. So I'm actually giving you the notes there. So saying when you have a negative gradient, when you calculate angle of inclination, it will give you a negative angle. And you must always take that negative angle and plus it by 180 degrees. But when you have a positive gradient, you will have a positive angle of inclination, then you will be done. So those are the notes, honorable members. We will do an example just now so that what I'm explaining makes sense. Okay, so very quickly, let's say we have, we will start with that one and say we've got that point there being point A. The coordinates, let's say, is 4 and 5. And then here we've got point B. The coordinates, let's say it is negative 5. And then maybe let's say this is 4. Can you guys calculate a angle? No, the gradient of line AB. Can you guys calculate the gradient of line AB? That is the first question. What is that gradient? The second question, the gradient of line CD. I will draw line CD just now, and then line CD, I will say is that one. As soon as you get that answer, just comment in the comment section, and you'll say M of AB, you tell me what the answer is. This one, let's say Y. Let's just say 4. X being negative 4. Maybe let me make it clear so that someone does not. For 4, the negative, no, it's positive 1. Yes. Very quickly, can you guys calculate the gradient of those two lines? We've got angle theta and angle beta. Let's see if you guys have got the answers for me. No answer. Guys, are you still working on it, or what's happening there? Okay, let me not rush you and give to work on it. Okay, I think that was the Manyagis. The Manyagis. Glad you responded to me, honorable member. I'll give you some time and not rush you. You might as well just do both and comment with one comment and say M of AB equals this, M of B, no, M of CD equals this. Nyaki, the moment we have 3 or more comments, just let me know so that I'll continue. I just need at least 3 comments. I'll compare and then we continue.
Yes, sir.
Let's see, are you guys still working on it? Okay, 2 comments. Okay. Got first 2 answers which are the same, then it's fine. I'll wait. Wait. No, not that. Okay. Let me say this, the gradient for this line AB will be positive gradient. If you get a negative gradient, it's wrong. For this one, it will be a negative gradient. If you get a positive gradient, then it's wrong. That's what I meant when I was saying the line that ends in the first and third quadrant will have positive gradient, and the one that ends in the second and fourth quadrant will have negative gradient. So just verify your answers are there. Let me see if we've got some more answers. Okay. We have that. Spider's iPhone and the Maatlis. There's definitely something wrong with your answers, honorable members. Again, the Manyakis is definitely something wrong. Maybe let me quickly do it so that you will notice where you might be going wrong. This is what happens. The formula will therefore be, no, not in red. Someone remember to mute your mic. Y2 minus Y1 over X2 minus X1. So what is your Y2? Your Y2, you can have your Y2s in your B. So Y at B is 4 minus your Y1, which is 5, divided by your X2 inside the brackets, it's negative, minus your X1, which is 4. Remember, letter B comes second, letter A comes first. That is why this is my X2, Y2. This is my X1, Y1. So if you punch this on your calculator, or even if you have to work it out, you have -1 at the top over -9, which therefore ends up as +1 over 9, because that negative and that they cancel. So that means the gradient for that line is equals to +1 over 9. For this one, again, formula doesn't change. Y2 minus Y1, X2 minus X1. Which one will be your 2? Which one will be your 1? D comes second. So that means this is your X2, Y2, X1, Y1. Always, because your Y2 is it's a negative, you must always put it inside the brackets. Minus, what is your Y1? No need to put inside the brackets. It is 4. Over X2 is 1 minus your X1 is negative. Put inside the brackets. You end up having -9 at the top over at the bottom you have, trust me, it will be that times that, which makes it +4. 1 plus 4, it ends up being 5. So that means you end up having -9 over 5 as the gradient for that line, -9 over 5. I hope you guys did see what I have done there. So now comes the time to calculate what is it? The angle of inclinations. Maybe let me use this space because I'm sure you did see how you calculate these things. I'm mostly interested in showing you how to calculate that angle of inclination. Remember, guys, I'm saying this serves as a revision in some of you, but as a continuation to some of you. So now let's see, when it comes to the angle of inclination, we can say the angle of inclination for the gradient of that line of AB will therefore be equals to tan angle equals, what is the gradient of line AB? We got it to be +1 over 9. To calculate that, it's just like your trigonometry. You will say tan inverse 1 over 9. Therefore, punch it on your calculator. You will therefore say shift tan 1 over 9. It gives you 6, 4. So that means 6,34. You must remember to say degrees. If you don't say degrees, it's wrong. Then this is your angle of inclination. Can you see? You substituted your positive gradient, you get your positive angle of inclination. So that means that angle there, it is 6,34 degrees. So now, let's see what we get when we calculate angle of inclination. It's actually beta there for that gradient of line CD. So now we say tan of angle beta equals, what is the gradient of that line? We got it to be -5 over -9/5. So angle beta is equals to tan inverse -9 that. So let's see. Go back, we say -9/5, and then when we close, can you guys see? You get -60,95. -60,95 degrees. So can you guys see? We substituted our negative angle, our negative gradient, we get negative angle. What does that negative angle mean? It means it actually gives you this angle. This is the angle which is 60,95 degrees. But that is not the angle of inclination, because the angle of inclination must start from this side until there. So that is why you have to plus it by 180 degrees, so that the angle that you get will be that angle beta. So that means you will say plus 180 degrees, and you get 119.05. 119.05 degrees. It is therefore your angle beta, 119.05 degrees. It is that angle. Why 180? The reason for 180 is because you remember we set angles on a straight line. That angle and that angle. When you take this angle and you plus it with that angle, they must give you 180 degrees. The sum of angles on a straight line equals 180 degrees. So that is why we have to plus there by 180 degrees, so that if we know what that angle is, we use 180 to know what that angle is. Guys, did I make sense there? Are we all okay with what I've done there?
Yes, sir. Yes.
Because this question, honorable members, you might need to expect it in an exam, and you will definitely be expected to remember that. Okay, then it's fine. It's fine. Another thing that I want you guys to know about is that let's say for parallel lines, or for the lines which are parallel, the gradient of line 1 will be equals to the gradient of line 2. So that means on a Cartesian plane, having the y and the x-axis, if you have that line there, and they also do another one like that, and for example, maybe they say that, or they don't say, but they just do that, then it means line AB is parallel to line CD. When lines are parallel, it simply means the gradient of this line is equals to the gradient of that line. Remember, the gradient, the other word for gradient is the slope. So it's like we are saying the mountain, this mountain A, the slope of this mountain A, it is actually the same as the slope on that mountain B, especially when looking at that point up to its highest point. So it's like if you had to climb mountain A, you will experience the same tiredness. I'm not sure if that word is legal, but you will experience the same tiredness as if you were climbing that one of B. Yeah, that's what the slope means. This line may be above that one, but at the end of the day, if you had to climb that line, you'll be as tired as having to climb that line, especially if you walk the same length. Yeah, I'm just trying to help you guys visualize what a slope is. Okay, it doesn't end there, honorable members. Maybe before I continue, let me just say, if they give you the coordinates of point A and B, and you calculate the gradient of that, let's say you get it to be 2, automatically it means even the gradient for this is 2. You don't need the coordinates of line CD. I hope you guys did understand that part. I want to now discuss perpendicular lines. But did you guys understand what I meant there regarding parallel lines having equal? Does it make sense to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, then it's fine. Then it's fine, it's fine, it's fine. Okay, looks like the screen disappeared very quickly. Let me just share the screen again. Okay, I think now the screen is showing, and blank page. Okay, so now very quickly, let me talk about perpendicular lines. So when it comes to perpendicular lines, we say when you take the gradient of line 1 and you multiply it with the gradient of line 2, they must give you -1. They will always give you -1. So an example would be this one where you have a Cartesian plane. Maybe you have a line like that, and then you have another line like that. Let's say this is line A, B, this is line CD. So if, for example, the gradient of this line, let's say it is 2, it obviously has to be a positive gradient. Let's say it's 2. And then let's say the gradient, maybe this is line 1 or gradient 1. And then for gradient 2, the gradient maybe is -1/2. When it comes in a question in an exam, they will say, calculate the gradient of line A, then you get it to be 2. Calculate the gradient of line A, what is it? Line CD, then you get it to be -1/2. Then they say, is line AB perpendicular to line CD? I'm not yet sure, but the only way to be sure, that's if when I say gradient of line AB and I multiply it with the gradient of line CD, I must get -1. That is what the formula says. So that means if you get -1, it means they are perpendicular. If you don't get -1, it means they are not perpendicular. So the gradient of line that, it is 2 that you multiplied with the gradient of that. Trust me, 2 times -1/2 will give you -1. Therefore, you will say what is it? Not necessarily the gradient, but you will say line AB, it is perpendicular to line CD. When we say perpendicular, what do we mean? It means the angle formed is 90 degrees. That's what perpendicular means. Again, honorable members, did you all understand what I've explained there? Lakankulunkulu leba la eltembele.
Yes, sir.
But wait, is it everyone who understood what I've done there, honorable members, or am I losing some of you guys? Guys, honorable members, are you sure all of us, we are okay up to this point?
Yes, sir.
Yes, sir.
Yes.
Okay. Then in that case, I will continue. And how am I going to continue? I will now get to this question. And then let's see, I want to cancel some of the coefficients. I will cancel this one. For now, let me cancel that one. And maybe later, we will revisit that question. This is too thick. Let me adjust it and do it. Let me do that so that it's okay. So there's a question, honorable members. Determine the distance of AB. Calculate the gradient of B D. What am I going to share? I'm going to add a question there. Determine the coordinates of M being the midpoint. BD. Okay, I'm going to add again there and do these. To be clear that you can start on table members. You can start. Calculate. You already know that it's angle of inclination. Proof that that is 30, yes. So that means this is the question that you guys need to answer. Guys, can you clearly see the questions that you need to work on? Is it clear for everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, then it's fine. Please do take a screenshot just in case, because yeah, my battery is low. This thing is on safe power mode.
But unfortunately, none of you will survive the rest of the day. Jimmy, Lou, take them out. I got business to do.
No.